Good afternoon, everybody. Welcome to class today. First off, I want to just quickly apologize for the delay in getting started today. I was in a big meeting where my presence was very important to try to get some things right for the college and making sure you all have the best access to services in the near future, specifically with a new website. So that was something that even I wasn't quite prepared for how long it would run. So I want to just tell you all how much I appreciate you for bearing with me today in this delay. And really, the live stream isn't going to take that long today because we already started it. Already started a lot of stuff that we were talking about last week. 2-week module. That's the great thing about that. We got just a couple slides of material to kind of talk about today, and then I'd like to spend some time writing a longer program just so we can see how things work in context. So before we do all that, just one quick announcement, and that is about next week. Right, so next week there won't be any live streams for any of my classes because next week on campus here at Cleveland Community College, it is spring break, and I like to kind of bake into my courses that week to where you can kind of take it off if you'd like to. So I have it as a part of the next module. If you look in, if you look in the begin here section and you look at my course schedule, you'll see that next week is 3 weeks for that module. That's because 1 week I kind of want you to just kind of take off if you want to. If you want to go ahead and start reading and start looking things over and kind of get a head start, you're welcome to do that, obviously. But, especially at this point in the semester when we've all worked pretty hard to get where we are, it's nice to just take a break, step back, enjoy a week off, and kind of regather ourselves so we can finish the semester strong. So I encourage you to take advantage of spring break next week. We'll be back to our regularly scheduled program the week after and get back into talking about working with files, which is pretty interesting. But today we're finishing up talking about dictionaries. And I do have a couple slides here, and I'm just going to kind of run through the slides just as you would. Just run straight through the slides. And then we will flip over to doing an example. And in that example, we'll see our execution of what we talk about in the slides. But as we get started, I'd just like to do a bit of a review of what we talked about last week. Obviously, if you want some deeper stuff into kind of where we started last week, that recording is still available for you to watch. So if you haven't watched that yet, or you need a refresher on where we started with dictionaries, then you should probably go back and start there with last week's live stream. But we essentially said that a dictionary is sort of similar to a list, right? So that's kind of why we teach these sort of back to back. When we were talking about lists a couple weeks ago, we said that our list is basically just a container of containers. And so we can kind of take all of these data structures and look at them in sort of the same way, right? Whether it's a variable, whether it's a list, or whether it's a dictionary, all we're really talking about is a series of containers. And so if we said that a variable is a single container that you can put data into or pull data out of, then a list is a container of those containers where you can reference each container within the big list container via their index locations. But now we're approaching the idea of dictionaries, and dictionaries are very similar to lists with just one key difference. Instead of referencing items within a dictionary by their index location, we can consider each item in a dictionary to be locked, if you will. We can draw some poorly drawn keyholes back on here again, like we were doing last week. And so on and so forth. So we have a lock on each of these containers that are inside of this dictionary, and they all correspond to a related key. And in order to access the data in one of these locked containers, we utilize the key to be able to get in there and get that data out and communicate the data that we want to. So instead of referring to it by its index location, we refer to it by its key. And this can prove to be very valuable when we're looking at certain types of program situations like the one that we're going to be doing in our example today. And now, just like in a list or just like in a variable, the data that's inside of these containers can change. But the key is immutable. The key is not able to be changed. Because if you lose the key, like if you lose the key to your house, you can't get in. Right? You can kind of think of these things as like if you have a post office box. Like everybody here at the college has a mailbox, and in order to access my mailbox, I have a key that I go open it up and I can take my mail out of it. So if you have a post office box, this might be something that you're familiar with, or if you're familiar with the concept of a post office box, this is something that we can kind of relate it to. You know, you have a key or you have a combination that gives you access, and then you can go in there and access the data or mail that's inside. And so that's what we're kind of talking about here. And last week we looked at, how we iterate through a dictionary and how we access certain items in a dictionary. And it was, in fact, very similar to the way we've handled lists the weeks prior. And as we, sort of wrap up the review here, we can kind of look at this slide, which I believe is the last slide that we looked at last week, that was talking about important things for us to know about dictionaries. And so these are kind of the big things that we have to keep in mind as we're working with a dictionary. One is that our keys must be unique. Every key, one key to one lock. Right? Like if you have a skeleton key that can open up many locks, well, when I refer to that key name to get into a container, which container am I trying to get into? You don't know, right? So we want to be able to have a unique key as a unique identifier for each container so that we can identify that container, get the data in, pull it out. If we have an existing key and we assign a value to it, if we reassign a value to an existing key, that's going to update the value that's inside of that container. And dictionaries are unordered, and while we can work with things in such a way that, they look like they have an order, we don't have to do anything in any particular order with our dictionaries. We can just kind of put data in there as we see fit. So even if, like in the example today, what I'm going to do is I'm going to kind of work with like a employee ID number as a key, so I could use something like 101, 102, 103. But if I wanted to, I could start with 107 and then go back to 101, 102, 103. It doesn't have to be in any particular order. Anything can be in any location. Programmatically, we can deal with ordering if we want to. It all just depends on what we want to do with the code that we have. So from here, we can kind of go back and we can look at some code. So as we are approaching a dictionary, when we are wanting to add a new key to a dictionary, we're going to set up a unique key name and assign a value to that. So for example, what I might want to do is maybe I might want to take the last key that's in the dictionary. Maybe I want to find the last key that's in a dictionary and maybe just add one to it to get this new code. Well, in Python, there really is no such thing as a last key. There is another bit of code that gives you an ordered dictionary. So in this instance, what we might want to do is either use some other variable that acts as like a counting variable that we can put here, or just have the knowledge of what our keys are. Just because that's kind of the way that it works in Python. So you might say, well, what I want to do is I want to find the last key and add one to it. That's going to make things a little bit difficult. But we can try out some things in our code to see if we can make certain things work. And we'll be doing this in our demonstration here in just a little bit. But we can see that if we have our dictionary name and then we put into brackets our key that we're referring to, we can just take that new key, whatever that key may be. It could be one that already exists in our dictionary. If it already exists in our dictionary, then we're reassigning the value of whatever container has that existing key in our dictionary. But if that's a brand new key, that's going to create and assign a value to a new key inside of our dictionary. In order to remove a key, we use the del command. So I'll say del name of dictionary key, whatever the key may be. And of course, when you lose a key, you also lose the value that goes along with that key. That essentially takes the entire container and pulls it out of the dictionary. Right, so this is going to remove an entire key value pair from your dictionary, this del command. So finally, to kind of wrap up, we have some other ways that we can access items inside of our dictionary here. We'll work with these, but these are methods. So I would say, dictionary name dot get, and then in the parentheses, the key. So I could get the value of a certain key that way instead of using the square bracket key name syntax, which to me, like this, doing the standard dictionary name square bracket key and key inside of those square brackets is a bit easier than using the get syntax. Although there are certain cases, which probably in your reading, about when we'd use get versus the regular syntax that we're using. Although that's not a huge deal for where we're at right now, right? Like we're just trying to learn some data structures, trying to, get engaged in a little bit of programming. So that's not a particularly big deal here. One of the things that we did last week was we iterated through a dictionary with a loop. And we have this items method here, so it would be dictionary name dot items would give you a list of items. So it would essentially do the same thing that we were doing last week as we were doing that for loop. It would create a thing with the items there, and then if we wanted to delete everything from a dictionary, we could use our clear function. Although that's not incredibly useful in a lot of scenarios. Although there are some instances in which it could be useful, which will be more relevant week after next when we start talking about persistent storage in files. But I said what we would do with this is we'd just kind of talk about this stuff, and then I'd kind of go back and show you everything at once instead of kind of going through and showing you one thing at a time like we normally do. So what I would like to do is find my REPL here so we can get started with a little bit of code. And here it is. So my idea here is what we're creating is we're creating a sort of an employee database. It's not really an employee database because there's no persistent storage. Right? When we get into talking about persistent storage in 2 weeks' time, week after next, we're still not really using a database, but we'll be using something a little closer. Because since this is all in volatile memory as we run our programs, whenever we stop our program and rerun it, we lose everything that we did here. But what I'd like to do is I'd like to create basically what is an employee database. So I'd like to have an employee ID that's going to be a unique identifier and a name for each of our employees. So we're going to take a name and an employee identifier and relate those two together. So let's think for a minute about what we would want to do or what we would want to be able to do in a program like this where we would have sort of an employee database that we would want to work through and understand. I would essentially want to be able to do 4 things. One is I'd want to be able to see a list of my employees. So I'd want to be able to print out a list of my employees, which makes sense. Another thing that I might want to do is I might want to add a new employee. So we'd want to be able to create a function where that's going to allow us to add a new employee. And then the other thing that I would want to do is I would want to maybe delete an employee. Maybe they got fired. Maybe they quit, whatever, you know. So I want to be able to remove that employee from my database. And I would also like to be able to update an employee. You know, maybe you had somebody that changed their name, got married, whatever. So you need to go in and be able to change their name value. So yet they have the same employee ID, but a new name. So these are our 4 functions that I'd like for this software to be able to perform. So these are the 4 primary functions that we're going to be writing in our program. And we'll also have to go back and, you know, write a little display function, that sort of thing, to get this to where we want it to be a full program. But let's start out, just do some code. And so I'm going to start out with my shebang here, like we always do. That's #bang /usr /bin /env Python 3. Very good. And so what I'd like to start out with is at the global level, I want to build my dictionary. So here I am at the, just wrote my shebang. I'm at the global level of my program. I'm going to build my dictionary here. I don't want to build it in any function because I want all of my functions to be able to access this dictionary and add to it, remove from it, print it out, whatever I want to be done here. So I want to build my employees dictionary here. And so if you remember back to what we talked about last week, when we're building our dictionary, we're going to set that equal to some items in curly braces. I might put, and we'll just set it up like this. Maybe 101 is Peter. 102 is Sarah. 103 is Jack. And 104 is, let's say, Rebecca. And so remember that after the last item in our list or in our dictionary, we don't put a comma. We comma separate everything else. You know, it kind of looks like JSON if you're familiar with JavaScript objects to some degree. You know, it looks like some JSON or some React hooks, you know, that sort of thing. Because really in other programming languages, we would call this like an associative array or... oh, what's the other term? I've lost it right now. It's fine. We don't need it. Go back to last week's. I said it last week. And so let's start out with just a really simple function here. And I'll use that .items method that we saw there on that last slide. So what I want to be able to do is I want to be able to get everything that's currently in our dictionary. So let's create a function, def print underscore employees. We don't need any arguments for this. And all I want to do is I want to be able to iterate through my dictionary and find the key and value for every employee number and employee name. So we're going to use that employees.items method or that .items method here. So let's just play with this a little bit before we run it. So what I'd like to do is for right now, and we'll refactor this in just a moment, I'm just going to take a variable. We'll call it X since we're going to be getting rid of this shortly, and set it equal to employees.items. And then we will simply print X. So now let's write our main gate here. And call this print employees function from here and see what it does. So print underscore employees. So let's just do a little testing with this. We're going to go back and we're going to refactor and remove this code here in just a minute. I just want to show you what this does by default. It gives us these dictionary items. And it gives us these dictionary items as essentially a list of tuples. So what we want to do is we want to be able to go through each of these so we can kind of pretty up this output rather. And so in my program, I can do this a lot easier. In fact, I think I want to keep X here and just write my for loop in relation to X. We could also, write it in relation to employees.items, but let's check out for. Remember, we have two elements in each part of our dictionary. We have keys and we have values. So if we said for key in X, print key. Let's see what this does. Okay, well now we're getting closer. Right, so each key is going to give us each segment of our dictionary. So if we wanted to bring this into something that we could work with, we would need to bring in our key value pair. And so what I would want to do here is I would want to say for key, comma, value, in X, print key. Well, now let's see how that's different. Now it's just printing the keys. Because really we can make this whatever we want to make it, right? This could be K and V, for example. And we're going to print K. This is relational to our dictionary items. Right? So if I go over here, I get the exact same results. So when I only had one variable in there, it was looking for each row as a whole. That's why we got everything that we got there. But now if I'm looking for two items, it's going to pull out each portion of each row because we have our key and we have our value. So what I could say here to pretty this up a little bit is maybe, let's see here, I have an ASCII bullet here in another window ready for me. So I can copy that over. Maybe ASCII bullet plus, now in this case, we'd have to do a little typecasting here because we can only concatenate strings. So since our keys here are integers, we'd need to typecast them into strings. Now remember that our keys could also be strings. Our keys could be, whatever kind of primitive type that we want here. Characters, strings, integers, floating point numbers, whatever. Right? We just can't change them. So in this case, they're integers, but they could also be strings if we wanted them to be whatever. We'll concatenate this with a colon. And we'll concatenate that with V. So now we're grabbing the string value of the key, putting it together with the name value of V. And we get something that looks more like a list that's clean and readable. I have an extra space in there. I might want to delete that out just to make it look more list-like. Right, so just like that, we've used our items method for our dictionary to create a little function that's going to print our dictionary out whenever we want it to be printed out. So that's one function that we can kind of check off our list. Right, we said we were going to print, we were going to add, we're going to remove, and we're going to update. So the next thing that I might want to do is I might want to update. You know what? Let's add first. Let's add first. And also we've got our print employees test here. We can remove this intermittent test, be done with that, because we know that that function works the way that we want it to now. So let's move on to a function to add an employee. Def add underscore employee. Now, in the version of this program I normally like to have you create the key. Which we could do that relatively easily, right? We saw how we would add something with a new key before. But I think what also might be interesting is if since we're just kind of working with this in this sort of way, I think it might also be interesting to sort of dynamically create a new key to add it to the list. So what we will do is we'll get this employee ID. We'll call it new EMP ID. And we'll set that equal to the length of our dictionary plus 101. So it'll be len employees. Right, let's just print this out to make sure this works the way we want it to. New underscore EMP underscore ID. Call that function behind our main gate. Add underscore employees. And so once we do that, we get 4. So we know that that works the way that we would want it to. So our new employee ID, since we left off at 104, should be the length of the list wherever it grows to, plus where we start. So in this case, 101. And so now, if we were to run this here, our first employee ID is going to be 105, which is exactly what we want. And then if we add another new employee, our list grows by 1, so the length of the list grows by 1. So the next one would be 106. So we get this dynamic sort of growth here, which is ideal. But we could also do it similarly with just having you put in the number, right? If you can figure that out, which should be pretty easy, then you'll be fine. So all we would have to do from here is get a new employee name. And set that equal to your input of enter new employee name. And then we could set the key to this value. So employees new underscore imp underscore ID equals new underscore EMP underscore name. And from here, we can just run our print employees function. Like that. So now what we're doing is we're going to be dynamically generating a new key, and we're going to assign a value of our choice to that key. And then we'll print the employees. So now we can test this to see if it's going to work. We've got our add employees behind our main gate, which is the function we're wanting to run. First, it'll dynamically generate our new number. Second, it will ask us to enter a new employee name. And then it'll do the setting of the dynamically generated key to the new name, and then it'll print out the list. So what I really want to do here to test this out, to make sure we get a good test, is I'm going to run our add employees function twice. So we can get it to give me one new one and then another new one, just to make sure everything's working the way that we intend it. So let's clear this out and let's run this just to make sure that this is working the way we want it. We're going to be asked to enter a new employee name. We don't have to worry about the key because that's already been dynamically generated for us. So if I enter Tom here, that's what we get. We see Tom added to our list. So now Tom is a part of our dictionary, and that's still in our volatile memory. Now when we stop this and rerun it, Tom will be gone. And so will his dictionary key there. So that's why we ran this twice, so we could keep Tom in memory and add somebody else, like Jane. So now when we hit enter here, if we did everything correctly, we should have 101 through 105, like we have displayed there previously, plus a 106, who is named Jane. perfect. Right, so let's just, take a brief sidebar to talk about what we could do with this information while we have it up. Right, like if we wanted to find out which individual had a particular ID number, well, that's something that we could do as well. Right, like we'd search for ID number 104 and have it return the value, which is going to be Rebecca. That's a way that we could extend this. We could search for the value and see which associated employee ID comes along with it. By just looping through and saying, oh, if the value is this, then give me the key. Print the key out to me in a similar sort of manner. So there are other ways that we can extend this past what we're doing here in this demonstration. So now we have 2 of our 4 big points that we've hit here. We're able to print out our list, and we're able to add an employee to our list. So what I'd like to do here is I'd like to write myself a new function. So I'm going to remove these function calls here because that intermittent test is done. I'm going to write myself a new function called def remove employees. And so for this one, what I'm going to want to do is I'm going to want to check to see if the key is present in the dictionary, and only remove it if the key is present. So we're going to add a while loop to this part. We'll just add a simple while true here. Because if the key is not in the dictionary, I want you to have the opportunity to put a key in there that is in the dictionary. So while true, we'll take our value of imp ID, and we'll set it equal to the typecast integer value of input enter employee ID. And so from here, we'll check to see if this is in our structure. So if imp ID is in employees, well, then we're going to remove it. So that would be del employees EID. And we'll print user employee removed. And then we'll print our employee list, say. So we'll run that print employees function. And then this is a successful execution of our loop. So we can break here. Our else condition is going to be to print unknown employee ID. And we should just go back through and normalize this to be all capitals, right? And then it'll loop back up and start at the top here to have you enter the employee ID again if the employee ID is unknown, right? So let's test this one out now. So we'll add a reference to our remove employees function here. And just like the add employees, we'll do this one twice. just to see it work successfully 2 times. So let's clear our console out here and let's try to run this again. Enter employee ID. So let's start by adding an employee ID that's not in there. So right now, since we just started this program anew, it just has these employees in our dictionary. Those ones that we entered in the previous tests are gone because of how this works in volatile memory. Hint, hint, that's why we need persistent storage with files that we'll be talking about in a couple of weeks. So I have employee IDs represented of 101, 102, 103, and 104. So if I enter in an employee ID of 105, I get an unknown employee ID and I get the opportunity to re-enter an employee ID. So if I enter in 103, which is a known employee ID, oops, I used the wrong variable name here. This should be emp ID. Whoopsie daisy. 103. And we see that that employee is removed from our list. So now we go 101, 102, 104. So we're running this twice just to see it work twice. So when I enter in 102, after I hit enter here, I should expect to get back a list of dictionary items that are just Peter and Rebecca, because I've removed everybody else from the list. So there's that. So that works as intended. So in terms of what we wanted to do, we can mark a lot off of the list. The only thing that we would really have left to do here in terms of functionality is an update function. So we can write that, and that's actually going to be really similar to our delete function here. So what I'm going to do is I'm just going to copy my delete my remove function wholesale, because I know that it works now, so I can delete my intermittent testing there and just paste it on in there. Right? Remember, that's one thing that I encourage you to do, is kind of take past successes and let them influence and create future successes. So now I know the majority of that code works. I know that I can just get in here and change some specific things, and then I'll have a brand new piece of working code. So we got to give this a unique name. So instead of remove employees, this will be update employees. Def update employees. While true, that part's still going to be the same. The only thing we're really going to change here is this part here. And we'll say we'll add a new EMP name here, or EMP update underscore EMP underscore name equals input enter updated name. Then we'll take our value, which is going to be employees, with the key of EMP underscore ID. And we're going to set that equal to the new name. So update underscore EMP underscore name. So remember, this is how we address existing keys to reassign values into existing keys in our code. We just set them equal to whatever new value that we want to put in them. And then we can print employee updated maybe. And print our employee list. So let's test that a couple times now, right? Because that's essentially all we want to do there. So we'll add an update employees, and we'll do it twice. I'll go back and fix my typo here, because this should be employees. You probably caught that while you were watching this. Typos happen. So now let's test this out. Give it a little test. We'll run it. Enter our employee ID. We know that we have 101, 102, 103, 104. Let's first test the condition of an employee ID not in the list, even though we should expect that to work. Unknown employee ID. Enter a new employee ID. Let's go 102, which in our list is Sarah. So let's say she doesn't want to go by Sarah anymore. She wants to go by Sarah Jane. Right, so we hit enter. We get the employee updated message, and we get our printout of our list showing our updated name. Maybe Rebecca doesn't want to go by Rebecca anymore. Maybe she wants to go by Becky now. So let's update her, 104. And she wants to go by Becky. And there we can see that update. So we can see that Sarah Jane has the updated name still, and now Rebecca is Becky. So that is another working function. So that's all we want to do with our dictionary, right? We completed the 4 things now with the dictionary that we have that is going to help us with this. So what we want to do now is we want to just write a piece of code that brings all of these 4 functions here together, right? So a piece of code that brings our print employees, our add employees, our remove employees, and our update employees, all of these together in a single cohesive program. So let's just write one more function for that. And this will be the function that we put behind our main gate at the end. It'll be the ultimate final function that we have to put behind our main gate. So I'm going to delete those from there. And I'm going to write a function called def employee table. We'll use another little while true loop. We'll have a variable that we call user selection, and we will set that equal to input make a selection from the following. We'll add some new line characters in here and really make this like something that works. So let's add a new line character. In fact, let me just copy this from my demo that I have over here so it doesn't take so long to do, because I have ASCII bullets and stuff in there. So just for the sake of time, I'll copy my working notes and paste them in here. So we just have a bulleted list here: A to add, R to remove, U to update, F to finish, and then just a prompt for your selection. So if we just want to see how this looks really quickly, we can do that. And just it's going to pitch half of a fit here just because the code's not finished. We're not doing anything with user selection. But I just want you all to see how it looks in the output. So I'm going to run this, and you can see how it looks here. Right, just A to add, R to remove, U to update, F to finish. Those /n new line regex characters to give us line breaks between everything, just to kind of make it look nice. So now we can stop this and clear this out so we can write our conditionals. And I can even take this and go ahead and normalize it. So I'll put my dot lower here. So we'll normalize everything to a lowercase letter. So whether they enter uppercase or lowercase, A, R, U, or F, it'll still translate to the same thing. So let's write our conditional. If user underscore selection is A, well, that's our add employees function. So that's add employees. That will run. Elif user selection is R. Well, that's our remove employees function. Elif our user selection is U. Well, that's going to be our update employees function. And we could say elif our selection is F, but I'm going to make it for anything else. So it'll be else. We'll print. Or you know what? Let's do it. Let's do it the right way. We'll say elif user selection equals F. We will print. Let's add a new line character and print thank you. And then break our loop. And then if it's anything else, we'll print invalid selection. Try again. So now we're going to keep looping through this and keep adding or removing or updating employees as long as our user wants to. And this loop will only break if the user puts in an F to finish. So we can add as many as we want to as long as our user keeps pressing A. As long as they keep pressing A, that's going to run our add employees function, and it's going to go through and do the add employees thing that we looked at a little while ago. So this is what we want. We can put this employee table function here behind our main gate, and we're good to go. We have a finished program. So we can run this finished program and test it out. We know since we did intermittent testing, we know our print employees, our add employees, our remove employees, and our update employees. We know that they all work. So we can just run this and test it out. Let's start out with an A to add. I hit enter there before I hit a character, so we got our invalid selection response. So we know that that one works. Let's hit A to add. We'll add a new employee. Let's add Tom back to our list. And then we get that we have Tom added in there. A to add. We can enter a new employee name. Let's add Jane back in there. So now we can see Jane added to our list. Let's remove an employee. We can remove 102, which is Sarah. Now Sarah's gone. Now this is one place where it is going to cause us some trouble with our remove employee function, or with our add employee function here, right? Since we're dynamically assigning values. So this is why it's easier to do the whole have you put in the number thing. And you could do that similarly, but I also wanted to do a dynamic thing just so you could see it. So this is a flaw. Because if I tried to do a new employee ID now, it would give me 106 again, which is a problem. There are ways around that, but we'll just kind of flow with it for this for now. We can update an employee name. Let's change Rebecca to Becky again. So that's 104. BCKY. Now we get that. And we can finish. And we get thank you. So aside from that slight little issue that we discussed there about our numbering, which can be easily fixed if we just change the way that we get our key. You know, we would essentially do the same thing that we're doing here for our remove and our update employees, but reverse the logic a little bit. So if it's in the list, we say already in the list, try again. And if it's not in the list, we add it, we run the code to add it. So, you know, different ways of doing similar things. It's all good, right? For our purposes. But this is a completed program with some flaws. However, you should also know how to fix the flaws. So this is where we're going to stop for today. We've almost hit a 1 hour mark, which is, you know, a pretty good time for our live streams. We're about 3 minutes or so short now, and by the time we wrap things up here, it'll probably be pretty close. But this is Dictionaries in a nutshell. Between last week and this week, we've seen different things that we can do with the dictionary, how we implement dictionaries in theory, and this being a more practical example of how we can implement dictionaries. And this flows into what we're going to be talking about in a couple weeks when we have our first live stream about files and utilizing files. Because the big issue here is the thing that we've seen before, that when I restart this program here, I'm restarting it with just the dictionary that I have here present in memory. So anything that I added, anything that I removed, it gets undone because that's just in volatile memory. So I want to be able to hold things for more of a long term. So that's why we kind of do things in this order. But that's where we'll stop for today. I'll give you this sample file along when I post the recording of the live stream today as well. Remember, next week, no live stream, spring break week. Try to get yourself some rest. If you're a little behind, next week might be a good opportunity to get caught up as well, since we won't really be doing anything active. But as always, thank you for watching. If you have questions, please let me know. I'm going to hang out in the chat for just a couple minutes in case anybody watching with me live has any questions. Thank you for watching. We'll see you next time.